we know about baffles and a lot we don't know. We can look at Lycoming's information, we can look at Continental's information, we can look at Piper's, Beech, Cessna. They all baffle their engines differently. They all cowl their engines differently. And each one and every one of us, as we build, are going to find that our temperatures and our problems are going to be different. And our fixes are going to be different. In spite of the fact that some of us have exactly the same engine installations and cowls, and some of us even the same baffles, there are going to be differences. And even minor differences, let's say for instance, the leading edge lip of a NACA will cause a flow change. And we could end up with, as David was mentioning before, the spiral flow, the vortex that enters a NACA inlet, is going to be a different diameter on one than on another because of the depth of ramp or the shape of a ramp, the diameter of the leading edge on the NACA inlet. So as the air enters the lower part of the cowl, this flow is entering, which I believe is for the left-hand side as we face forward, is going to be clockwise, the right-hand side counterclockwise. And depending on also the size of your fuselage, the radius is how clean the fuselage is, you're going to have different speeds and different rotation rates. So take the information you hear with a grain of salt and then look at all the things that might pertain to your aircraft. If you've changed your inlet, some guys have a ram air inlet in their underneath the engine. They've changed the inlet elbows. Inlet elbow sizes have something to do with the airflow underneath the engine. There are just hundreds and hundreds and hundreds of things, right down to where you run your wire bundles underneath the engine and oil cooler lines. How many of you have built baffles from rotating plans?
I've started building them. I haven't finished them.
Are you having any trouble with the flat sheet bends? Making that one sheet conform with the backside of the engine?
Oh, yeah. That's one I haven't made yet.
Yeah,
I'm making a pattern out of heavy cardboard.
That's a good idea.
Take it off.
Real good idea. We've done. I started baffling engines with a custom aircraft builder in Compton by the name of Baffles. And he used that same technique on any engine he worked on. He'd take sheets of heavy poster board and cut it to match the engine, depending on the cowl arrangement. We have some here that we've been working on and produced a number of different sets. Would you pass this around, guys?
Do you make those for sale, finished?
Yes, completed. We tried to make flat sections, cutouts, and sell the pieces, but we don't supply plans, and it made it very difficult for the builder to assemble. And we do our best work with an engine and with our templates and do the assembly complete.
Which engine is that?
This is an 0290 ground power unit. It's the same engine that's on my airplane, and there are several of these flying. This was built by the late
Lynn Bernard
in Long Beach. He's built a lot of 0290 ground power units up. This is a D2 version with high compression pistons. The way these go on,
Dave, before you start, what is the basic philosophy of Rutan's design? Is it just cover the engine and be done with it?
well, he doesn't treat the engine as though we're 4 cylinders. He builds a box generally around the engine and says, okay, we've got positive air pressure below, we have negative air pressure above. We'll generally enhance flow through the cylinders. You'll notice on the Rutan plans that he does not address the condition that you have an intake valve on one side and this is the exhaust port on the forward side and an intake port on the back. He doesn't baffle the center cylinder at all at the head. He baffles the center cylinder on the cylinder section itself, but not the head. And too many occasions I have seen the exhaust blades here discolored. And if you're going to have damage in an engine, usually it occurs on the exhaust port side. When most of you guys talk engine and you talk about exhaust valves, what do you talk about? The expensive valve versus the inexpensive valve, sodium filled versus. If you're going to have problems, more than likely this is going to be the first place you'll have it, on your exhaust port side. And one of the things that we've done with this system is we made a baffle that cools the exhaust port side. This drops down in between and forces air over the inner and the outer fin. There's another baffle that goes on the other side. We cool them both. Although for no better reason than there's no reason to not cool both sides. Righty. No 320 set here. Probably all going to want to take a close examination of this and take a good look at it. They drop in between. We no longer baffle just half of the cylinder. This information comes from Mike Melville, and he feels that too much of the air was not circulating around the bottom cooling fins, that you were getting a general flow that was working on the top side of the cylinder and the wall of the cylinder, but not the underside. So what this does, this wraps around the cylinder. It goes all the way, almost all the way around on both sides, forcing the air that we have got from underneath to pass over as much of the cooling fin as possible. This has proved very effective for Mike Melville. He is cooling a 180 horsepower engine with a 12-inch wide NACA, 3 inches high, with a baffle arrangement that's very similar to this. And he is producing many, many, many more BTUs than I ever produced with my engine. And with a smaller inlet, he is cooling that engine.
What's the standard NACA? 15.4?
The NACA that Herb Sanders developed is 15.4 and much longer. This is a lot of volume. And if all of this is done correctly, you don't need that much volume. They begin to get a little more complicated when you start wrapping the side and end of the cylinder. This is back. You can pass me that sheet back when you guys are done with it.
Shall we remove the other plug wire?
They're not in the way. The other side works. Screws with us.
On this engine, Dave, your baffles have to go on before you hang the engine.
Wouldn't Hoyt? No, wouldn't actually have to. Yours was very, very, very close. I could not ascertain with your engine exactly where your dynafocal ring was going to infringe beyond this plane. That's why I had to leave a flat sheet and cut into it in the forward section here and then have to cut to it.
I just meant on this sheet, you would actually cut it out.
Yeah, I'm sorry, you're right. This has to be installed before, because your engine mount rubber goes right directly up against it and acts as a retention for this sheet,
I see.
conical rubber itself. Because of the way this engine is configured, this inner baffle, this one here, has to be made up previously and bonded in place with silicone against this surface. Then this surface right here, assistance, this right here interfaces against it. When this is installed, you put silicone in place, which makes the seal across this face. The idea here is to baffle the engine as though you're individually making sure no air leaks past any given cylinder. Silicone seems to be the most widely used method of sealing up an engine. Let's pick up the top two bolts here. There should be a lightning hole here. This is not going to be as rigid as it is. Nut plates here so you can remove the two halves. And the front section. We've also been installing our oil coolers in this panel right here.
Is that oil cooler full of
agree.
That's my only worry about putting it there.
This flange here, this is different here.
There's one above Dan's, above
Yeah,
his
that's an
airplane.
03, that's set for 0320s.
That's
This front flange was cut for an 0290D2, which is essentially the same block, except this is a GPU flange that has been removed. So what is happening right in this area right here, this is much larger in diameter right now, just this area, than it would be for a D2. So this is the only thing that's really infringing, which we're going to have to do for him. And we mount the oil cooler here for one reason. One thing, on my engine, I have my coldest cylinders are number 1 and number 4. And the oil cooler, I've had a little bit of leaks at this flange, and the indication is that the oil that's been slopping around in this area. I get a blast of air that goes through my oil cooler. I've never seen higher than 180 degrees oil temperature at any time. And I get a blast through here that has been very effective in keeping a previously very dangerously high oil temperature on. When I drop my cowls, I don't have to pull my oil cooler off of the cowl, which was a pain in the butt for the ones that I had before.
There apparently is a lot of pressure on the back side of the engine. The Crydells have put their air filter on the back side as well. And it takes quite a bit of pressure, and they don't have any drop in pressure when they put it to carb heat, ram air in other words.
Repeat it again?
When they have the filter on the back side of the engine, it's evidently taking so much air
Backside. What do you mean by backside?
towards the prop,
Okay, they have the filter.
down below, and down below the oil pan in the back.
Mm-hmm. Oh, in this area here.
Down here, yeah. And it's taking enough pressure back there that they're getting quite a bit of pressure into the carburetor.
Oh, I can see by the airflow, the oil flow on the inside of my cowl and up on my baffles, the blast of air hitting that backside is much higher than it is anywhere else in the engine. And their feelings about airflow being directed at the cylinders for cooling, from what I've seen in the past, that's probably the most accurate summation of the problem. I made the assumption that the under plenum, this area all out here, was high pressure. We've got a massive air going into the bottom of the cowl, creating a positive air plenum. We have an opening here and a propeller. Assuming that we have a negative pressure here, suction on the backside, the propeller pulling air out of this area. And that it's not proven to be the case. Mike's oil cooler here, with a vent at the top of the cowl, if our original assumptions had been correct, we would have gotten immediately this positive airflow, venting itself to negative airflow. The first thing he did was he vented with a duct from the oil cooler to the baffle. No flow, zero, 260 degree oil temperatures, nothing. The last thing he did was where the NACA duct ends at the firewall, he put a kicker plate, picking at boundary, just a little bit more than boundary layer air, came below the surface of the NACA duct, around the corner, and pointed up. Oil temperature went down 60 degrees. Immediately, bang. I've had 2 mag failures on this side. I have gills on my cowl right here, and trying to induce some of this positive airflow past my mags. I've had a second mag failure, brand new mag, 170 hours on it. And I would not be a bit surprised if it's because of the fact that this is completely and totally stagnant air, temperature-wise. And we need to do, if we want to cool this area, if we put an oil cooler back here, we need to augment that flow with that kicker plate. And it worked for him very, very well.
The Crydells advocate that too.
Yeah.
The Melville kicker
Why,
plate or whatever it's called.
why put the oil pressure in that?
You mean the oil
cooler?
Oil cooler?
Why not put it where you mounted mine?
His baffles are different. His baffles are identical to Bert's, and there is no place here for that oil cooler. The reason I kick aft and come down is so that I have less of a plenum in this area. When the air leaves the cowl, I have less air boiling here because of a huge pit that is created by a vertical plate running right to the bottom of the cowl. I didn't want the dead air. On Jan Van Ort's, when I baffled his, I came out and diagonally went to the very end of the cowl and ran his alternator belt through 2 small holes in that baffle to the alternator below. Oil cooler mounted here, and he has never had, with a 12-inch NACA and an 0320, he's never had temperature problems with oil or cylinder head.
My oil was never gone up past 200. I've flown out of Palm Springs and Lake Havasu, 110 degrees.
Well,
No problem.
that
at
oil
all.
cooler position is
Ideal.
exactly as Cessna Type 3 Beach.
That's an
It
ideal
takes,
position
it
for
takes advantage of we have absolutely no doubt that this being the furthest, or almost the furthest position with the oil cooler in place, is going to get ram air right through and in the direction of flow.
As a matter of fact, I wondered about that in the wintertime, whether I should be closing that off.
Well, I know that with the way I fly my airplane, the way most of us will be induced to fly our airplanes, is that you have a tendency to put the nose down because of the way the airplane handles and come from wherever your altitude is. You're not going to baby the airplane to your lower altitudes, and you're going to have a tendency of shock cooling your engine. If there's any reason to put cowl flaps on your airplane or on your oil cooler or anywhere, it's because of that tendency. You wouldn't just drop the nose and dive a Cessna 152 or a 170 because of the way it feels and it handles. That's not the way your lungies is going
I
to feel.
understand Dick has a cowl flap, essentially closes his cowl off now
At the NACA?
at the NACA.
Yeah, I think it's a good idea.
And he also... is-
Dick?
Kreidel.
Oh, okay.
Not
he's
Dick
got a
Kreidel, I'm
flap in
sorry.
there, doesn't he?
Not Dick Kreidel,
Rutan?
Dick Rutan.
Yeah.
And he claims that he actually goes about 3 miles an hour faster with it closed, which makes sense too, without having...
He is ram air.
Essentially, he has a ram air, yeah. So he closes it off down there somehow so that on descents he's not overcooling the engine.
Yeah. That's the only thing I worry about when I'm coming into.
So we need really a design on the NACA, for those who are building NACA, that kicks up the bottom of the NACA, kind of like Ian Aiton screw.
See, Dick's got the mail scoop.
Yeah.
Yeah.
He's got a big, like a butterfly valve in here.
Yeah, we were talking about that about a month and a half ago. He said that he feels that when the butterfly is closed, it creates a pressure wave forward of the duct that acts like a deflector, and it gets better, gets less drag in the area if it's closed than when it's open.
I think a ramp on the NACA might be even more attractive in that sense.
Well, that's what Cordell's doing.
I don't think he's done that yet.
That's a long ramp.
No, I don't mean the whole length, I mean just somewhere in front of the opening. So that
Don't you remember he had that foam block that he had 5 minutes in place?
that's inside the NACA,
It's a splitter to direct air.
Yeah,
and
where are you talking?
outside the NACA.
You talking more oil pressure, oil temperature, or
Cylinder,
engine?
cylinder temperature.
All cooling.
Yeah, all cooling.
Any cooling in the engine. You evidently can really overcool the engine on descent with these planes, especially the bigger engine.
Yeah, cylinder.
The thing that I had thought about for a NACA is maybe right at the entrance, right where it's the smallest. As critical as those things are, the shape of them, if you could make a little fence that just drops down, the thing might only be that big, but it might disrupt the whole way that thing works enough to,
Spoiler?
yeah, just render the thing completely useless.
An idea.
Just a little tiny thing right at the beginning that would...
Speed brake, so if
Yeah.
it did anything to increase drag, it wouldn't make much difference.
Yeah, you're trying to come down anyway.
Something to disrupt the NACA
Yeah,
itself.
just right at the thing would be about that long and that deep.
Now, you make up these cowls now in full kit. You need the engine there at the shop to do it most of the time, right?
Yeah, unfortunately with Bill's, we were able to get 3 sets off before he got his engine back.
What engine was that? He
No,
had?
320.
And we charged him extra for it too.
It takes us about a week and a half
Let me look at this.
to make up a set.
What do you sell the set for?
$1,250.
But that includes a lot of things.
That includes installation,
Rivets.
baffle seal, rivets, oil cooler installation. The materials for the baffles does not include the oil cooler lines or the fittings, but includes everything else. And this is where we've got 1, 2, 3, 4 airplanes. We just baffled an O200 similarly, which was an airplane engine that was designed specifically for one type of cooling, and it's all downdraft. Consequently, the cylinder shapes lent themselves to baffles being on the cylinders for downdraft cooling, and we were updraft cooling, and we had nothing to mount to, no places to put screws, and it was the roughest baffle job we've ever had in DDA, and Andy handled it beautifully. Really, it really came out nice. We haven't had them tested yet, but the wraparound cylinder seems to be working very, very well.
Give us a comparison. You ran these baffles on that commercial Long Easy up in the central state, and then tested them for cooling. What was the comparison before and after?
Well, the engine they had on before, I don't have as good a comparison as I'd like to have. They had an 0235 C1C with rattan baffles on it, and they fried 2 of the cylinders. I put on an 0320 B1A, which has the 18-degree mount, and essentially made the baffles in the titanium shop for the SR-71. And they supplied me with most of the materials I needed. And the highest cylinder temperature we experienced was 385 degrees, which was in the summer, during break-in. I know that 2 of my cylinders are too cold, number 1 and number 4. And I'm going to have to restrict the opening on the cylinder, either above or below, to decrease the flow, to balance the temperatures. But even without the ramps we talked about before, underneath in my NACA cowl, I have not been able to get any one of the cylinders to ever go above the yellow line in the temperature. Just, they never reach the green arc 1 and 4.
How do you set up the temperature probes to check your cooling as you're going through the process?
Well, if you talk to Lycoming, they're going to tell you one thing, but we have another. Andy was talking about the way Lycoming sets up an engine for probing and testing. And their engines were designed for downdraft cooling. Anytime you have an aircraft engine with an exhaust port on the bottom, that engine was designed to be cooled from above and the airflow going past the exhaust ports on the other side. If you want an updraft cooling engine, you buy an IO540 M1A5. The cylinder is exactly the same as the KI5G, which looks just like these cylinders, except that the exhaust port's on the opposite side. So when they set up, so when we use the probe port, for like the Rochester probe or the B&Ds or the Alcors, we are going to put our probe in the bottom probe port, which was designed to take temperatures as the hot side on a downdraft cooling system. We have right there the possibility of a built-in error. And then Lycoming says, are you using spark plug terminals? And you say, well, yes, I am. But I've got them on the top side, which is the hot side. I said, well, all that information is absolutely inapplicable to any test data that we have. But they never mentioned to you that that test data was specifically for downdraft cooling. So where are we? We don't really know. We don't know what their engineering data is. We don't know what temperatures we can cross-correlate with information that we're getting from the bottom port. I can only tell you from the very bad experience I had with glazing cylinder walls with my first set of baffles and cowls. With the probe from the spark plug position, I was getting consistently temperatures in the 485 and 500 degree ranges on my cylinder heads. And when I pulled things apart and found glazed cylinder walls, it all seemed to prove out exactly as I was getting information. And I was also getting a correlatable drop in oil pressure when my temperatures reached 220 degrees on the oil. At 230, 20 pounds of oil pressure went right out the door. As Tom can tell you. Out of Mariposa, Yosemite, at 2,000 RPM, we couldn't keep the temperatures below 260 degrees on the oil temperature. And that's when I decided it was time to pull the engine apart and find out what's going wrong. And I really don't know what to tell you in regards to the temperature probes that we have and the gauges that we have for an updraft cooling system. I can tell you what temperatures I'm getting and are livable and have not damaged my engine yet with 400 hours on this engine since rebuild.
Now you say you have your cinders are on the top.
No, mine used to be on the top with the old system when I fried my engine. Now I use a Rochester probe on the bottom side in the acceptable port.
That's what you have now?
Yeah.
With the updraft?
Mm-hmm. Updraft
Well,
system.
So does that,
like, where are we? We don't really know.
okay, my question was, isn't it then better to put the spark plug cinder on the top spark plug?
We still, at that point, we still don't have information that is directly correlatable to something Lycoming says is acceptable. We don't know what that means. Is it hotter there than anywhere else on the engine and acceptable everywhere else? I know a lot of people have gone through a lot of unnecessary paranoia where the temperatures they saw on their gauge and they sweated everywhere they went. And then 2 years down the line, someone says, well, why don't you check your gauge? A little hot oil and find out what that
Dave,
gauge
did you ever
actually
try
says.
those heat taps?
Yes, as a matter of fact, I had.
Change color?
Dick Kreidel gave me one, and that's when I
Well,
found
you
out
can
my
get them
gauge.
all different temperatures, you know, you can put them all over the thing.
That's probably the best way to do it. That's probably the simplest way to
Then
do
you
it.
know exactly when they change color that it's reached that temperature.
Mhm.
I'll see if I can find some.
We might be able to get some information from Bob in regards to what this correlatable information might be. Andy says that when they set up an engine, they go to 30 different points on a cylinder when they're setting up baffles for an engine to make sure that the temperatures are balanced, and that information can be correlated to the information they get off that one port.
The other thing is that each probe is different. And you have to put them essentially into a pot of water and find out how they differ, so that when you're turning your gauge and you see one cylinder's hot, it might be quite the opposite. It might be the only cool one in the whole group, but your probe is hot. So you have to be sure that your probes are correlatable, or at least find a number that subtracts from each
Stick
that
them all
match.
boiling water together, you know.
Put them in the same common thing, and then rotate your switch through to see where they are.
You might want to use oil. I don't know if you can get
Yeah,
water
you can
hot
use
enough to check. You can get it to 212 and find out, but you want to get up to around 400 degrees to find out.
Dave, information I'd heard was that the probes are the only acceptable way, that the spark plug sensor is not really very good.
Well, we don't know if it's giving us accurate information at that point, and we can correlate it to what's happening on the underside, then it's pertinent. But if we don't know what it is, what this means to the port underneath, what are the two experiencing? If we know what it means, then I would think the information is usable, so long as the temperature that it's reading is accurate.
But then it's not necessarily true then that you shouldn't use the spark plug sensors.
I would agree. I would say that as long as you know what it means
Yeah.
in relationship to the other port.
Yeah, there's nothing wrong with them. They're reasonably accurate and all that. It's just, now that you got this information, what are you going to do with it?
Right.
That's
What
the
does it
problem.
actually mean in regards to the healthy condition of your engine? Will it continue to run? Any questions? There are a lot of things that we do a little differently than Lycoming or Continental does. We install our baffles. The middle baffles, the small ones here, we silicone in place. Silicone on the face, slide them in, and forget them.
Use the high temperature silicone?
No. My engine, when I first baffled it, I installed a fiberglass silicone impregnated baffle in this area. A piece of bid, cut it on the bias, smeared silicone on the aluminum plate, stuck it in, pressed it, rubbed it until I noticed it was beginning to go translucent, and then put silicone on the surfaces. And as I put the glass in place, I folded the ends underneath so it wouldn't have a raggy edge, and tried to keep them far enough away from the edge of the cooling fin so I could get air past the cooling fin, and then bonded them on. And even with the high temperatures that I had, of in some cases over 500 degrees and oil soaked, I had a devil of a time pulling them off. Andy and I have both experienced certain things about.
Go to the plumbing store and get the cheapest stuff they got.
It's exactly
It's all the
same.
same.
The same.
Oh, that's true.
And what you buy for $1.35 in one container and pay $3 for another.
Came out of the same bag,
Same
probably.
batch, same stuff. Buy the clear or the white.
I get the stuff that for it's just caulking silicone, the stuff you get in the big
tube.
It's cheaper to buy that way. We use that on Predator. All over that airplane.
Sticks
So,
to hot stuff.
yeah.
If your surfaces are clean, clear stuff is just as good as anything else. The red I found is chalky and does not have near the strength that the clear stuff does.
And it doesn't seem to want to cure in a large buildup,
Right.
which is easy.
It's got some tendencies that. Andy, you were talking about getting silicone to cure.
Water is like a zip kicker for silicone.
Spray it with water.
No. Spray bottle.
I had no idea. We
Moisture is what silicone needs
Yeah.
to cure.
What we do, one of the reasons that we put the silicone in place is not just for attachment, but if it does not fit the surface absolutely perfectly, what's going to occur is vibration is going to cause the baffle to wear through on the movement. Yeah. So we bond them in place for that reason. It's sound and vibration. Makes them difficult to remove later.
First of all, what information do you need for somebody who isn't nearby and doesn't have an engine nearby to make these things? When somebody sends for them from Texas, for example, what do they have to tell you? Model of the engine and that's it?
Well, because of a small operation, I deal personally with the client. I meet them, I build them back. If I happen to have an 0320 in the shop and someone calls me from Texas, and their needs and what I have happen to match, I get a set of baffles. I won't ship cowls. I won't deal with the postal department in that regard, or UPS. I won't make the crates. If they want them, they have to come to me to get them. So that's the limiting factor.
And what do they do to install them once they've got them ready like this? I know you slip them on, but is there a particular order of things?
If they're out of state, then they're going to do it themselves. They don't supply plant.
Yeah.
But if I'm in the area and they're in the area, I install them.
Do you have to drill holes or anything like that?
They've all been drilled for screws, and the curls have to be drilled for safety wire. And something that we've been doing lately is when we safety wire one flange to another, we drill 2 holes on both sides, run a piece of safety nyloflow tube between the 2 holes, run the safety wire through the nyloflow, out the other hole. This is to prevent the wire from pulling through the aluminum. And we spin the safety wire, tighten it up, slide another piece of nyloflow over top so that when it's sitting on top it doesn't wear through aluminum tubes or through fins. Pass it through the hole, go through another piece of small nyloflow and tie it off diagonally on one side while it's all very tight. And we do that between the cylinder above, below, and on the small ones at the top.
Your $1,200 includes the installation?
Complete installation. Baffle seal, safety wire, silicone, screws, oil cooler lines, the installation of the oil cooler into the baffle as it was made with reinforcements to prevent it from cracking. Then when it's all installed in the engine, we trim the baffles to match the cowls, and then put the baffle seal in place and make sure that the engine is ready to run.
That's cheap.
It's a lot of work.
Saves a good 2 weeks, at least.
2 weeks
At least.
for us and a month for you.
In a month for me,
And if you've never done it before,
For 2 months.
And it's
Let's
a
do
beautiful.
it again, Coughlin.
It's I've learned an awful lot. I've built about, I would guess, about 25 sets of baffles for different airplanes. And not one set, from the first to the last, was the same. Every set got an improvement from the inside from the next. Like we learned tonight, this doesn't fit. Questions?
Everybody's in shock from 1,200.
That's cheap.
You might want to come up and take a look at how they fit.
Sure do.
They don't.
Almost all.
Well, you bring that over, Steve?
Upside in.
Should tax the overstand.
Yeah, just bring it in here. Bring it up.
Fly it through the window or something.
I don't know what the state right now is. My pop
Anybody want these bearing holders?
Yeah, guy did a nice job.
There it goes.
I just welded it.
Pretty rapid.
Somehow, I don't know what it is, he collides somehow.
Yeah.
Well, Eric and I have never had a problem.
With what?
Dave,
Oh.
over the long term.
That's on tape now, you know.
That was over South Carolina.
Basic case against the lawyer, right?
Right. What got you now, Dave?
That thing was long.
You can erase now, Eric.
I was in blank at one time.
It's heavy.
I've had a lot of fun too.
That didn't come apart. Had a Western one time, and a snap roll in. Perfect.